Have you ever wondered how the sun, the very core of our solar system, came into existence? The birth of a star, especially one as significant as our sun, is a fascinating tale of cosmic proportions. Approximately 4.6 billion years ago, a dramatic event took place in the vast expanse of space. A cloud of gas and dust, seemingly insignificant in the grand scheme of the cosmos, began to change. Influenced by the intricate dance of cosmic forces, this cloud started to condense under the relentless pull of gravity. As the elements within this cloud, primarily hydrogen and helium, were drawn closer together, a dense region formed at its core. This was the beginning of a protostar. Despite its humble beginnings, this protostar was destined for greatness. As more and more material was pulled into this growing protostar, its mass increased. With this increase in mass came an increase in gravitational pull, drawing even more gas and dust towards it. This continuous influx of material caused the protostar to heat up. As the core of this protostar heated, a remarkable transformation began. The intense heat and pressure within the core initiated a process known as nuclear fusion. Through this process, hydrogen atoms combined to form helium, releasing an immense amount of energy as light and heat. This was the pivotal moment in the birth of our sun. The protostar had ignited, transforming from a dense hot ball of gas into a shining star. The energy released by nuclear fusion prevented further gravitational collapse, creating a stable balance. The light and heat generated by our newly formed sun began to push against the surrounding cloud of gas and dust, dispersing it and creating a clear space around the star. This marked the end of the sun's birth and the beginning of its main sequence stage, the period of a star's life where it burns hydrogen in its core to produce energy. Thus, from a nebulous cloud of gas and dust, our magnificent sun was born. Now that we've seen its birth, let's explore how the sun evolved over billions of years. Imagine a celestial being, our sun, maturing and transforming over billions of years. To understand this, we must first understand the life cycle of a star. Stars, like people, have a life cycle that consists of birth, growth, middle age, old age, and finally, death. Our sun is currently in its middle age, also known as the main sequence phase. In this main sequence phase, the sun is in a state of equilibrium. The inward force of gravity is balanced by the outward pressure from the fusion of hydrogen atoms at its core. This fusion process creates a tremendous amount of energy, causing the sun to shine brightly and emit heat. Interestingly, as our sun continues to burn hydrogen in its core, it is gradually getting hotter and brighter. This might seem counterintuitive, but let me explain. As the sun burns hydrogen, it creates helium. Over time, this helium accumulates in the core, causing it to shrink and become denser. This in turn raises the sun's temperature and increases the rate of hydrogen fusion, making the sun brighter. You might be wondering, how does this affect us on Earth? Well, a brighter sun means more heat reaching our planet. While this won't happen for another billion years or so, it's a fascinating fact to contemplate. However, don't start packing your sunscreen just yet. The sun's increase in brightness is a very slow process, and it won't significantly affect Earth's climate in our lifetime. So there you have it, the evolution of the sun. A process of transformation that spans billions of years, and we're living right in the midst of it. It's remarkable to think that our sun, a star we see every day, has such a dynamic and intriguing story. Our sun, though middle-aged in star years, still has a vibrant life ahead. So, we've learned about the birth and evolution of the sun, but what makes it so powerful? Well, the sun's might comes from a process known as nuclear fusion. This is a reaction that occurs deep within the sun's core. Picture, if you will, a place of unimaginable heat and pressure, where the rules of physics as we know them start to bend. It's in this crucible that the magic of nuclear fusion takes place. Let's break it down. The sun is primarily made up of hydrogen atoms. Due to the sun's colossal gravity, these hydrogen atoms are squeezed together under immense pressure. When they get close enough, they merge to form a heavier atom, helium. This process is called nuclear fusion. But here's the fascinating part. The combined mass of the helium atom and the released particles is slightly less than the original mass of the two hydrogen atoms. Now you might be wondering, where does the missing mass go? According to Einstein's famous equation, E=mc2, mass can be converted into energy, and that's exactly what happens in the sun's core. That tiny bit of lost mass is converted into a vast amount of energy, which then radiates out from the sun's core, through its outer layers and then into space. This energy is what we experience as sunlight. It takes about 1 million years for this energy to make its way from the sun's core to its surface. But once it's released, it takes just over 8 minutes to reach us here on Earth. This energy is so enormous that it powers everything from the smallest microorganism to the largest cities. It drives the weather and climate, fuels photosynthesis, and even powers our modern world through solar panels. And so, this incredible process of nuclear fusion, happening millions of miles away in the core of our sun, fuels not just the sun itself, but all life on Earth. This incredible process fuels the sun and ultimately all life on Earth. The sun's power reaches far beyond its fiery surface. But how does it affect our home, Earth? You might be surprised to know that the sun plays a crucial role in Earth's climate and weather systems. It is the primary driver of Earth's weather patterns. And without it, our planet would be a frozen and lifeless rock. The sun's rays heat our world, creating temperature differences that generate winds. These winds, in turn, drive weather patterns, creating everything from gentle spring showers to powerful hurricanes. But the sun's influence extends beyond just weather. It also plays a vital role in shaping our planet's magnetic field. The sun constantly emits a stream of charged particles known as solar wind. When these particles reach Earth, they interact with our planet's magnetic field, creating the stunning phenomenon we know as the northern and southern lights, or auroras. These dazzling light shows are not just beautiful to behold, but they also serve a crucial function by protecting our planet from harmful solar radiation. Now let's talk about life itself. The sun is essential for the existence of life on Earth through a process called photosynthesis. This is how plants convert sunlight, carbon dioxide, and water into oxygen and glucose, which is a type of sugar. This process not only provides food for the plants themselves, but also produces the oxygen that we breathe. Without the sun, there would be no photosynthesis, no plants, no oxygen, and thus, no life on Earth. From the weather patterns that shape our days to the magnetic field that protects us, from the energy that fuels our planet's life to the very oxygen we breathe, the sun's influence is all around us. It is fundamental to life as we know it, powering our world in ways that we often take for granted. Without the sun, life as we know it would simply not exist. We've seen the past and present of the sun, but what does the future hold for our star? Just as people, planets, and even galaxies have a life cycle, so too does our sun. And it's a future that's as fascinating as it is far-reaching. In approximately 5 billion years, our sun will exhaust the hydrogen at its core. This will trigger a series of events that will lead to its transformation. The sun will expand into a red giant, becoming hundreds of times larger than its current size. Our once friendly neighborhood star will become a behemoth, its outer layers stretching out to the orbit of Mars. But what does this mean for Earth? For a start, our planet will get significantly warmer. Oceans will evaporate and life as we know it will cease to exist. But before you start packing your bags for a one-way trip to another galaxy, remember this will happen in billions of years. After the sun's red giant phase, it will shed its outer layers, creating a beautiful cosmic spectacle known as a planetary nebula. The sun's core will remain, now a white dwarf, a small, dense, and hot object. This white dwarf will shine for billions more years before cooling and fading into a black dwarf. By then, it will be nothing more than a cold, dark, and virtually invisible remnant of the sun we once knew. But what about Earth? Well, if it survives the sun's red giant phase, it might orbit the white dwarf that was once its sun. However, Earth will be a barren, lifeless world, far removed from the vibrant blue planet we call home today. While the sun's future may seem daunting, remember, this is a process that will take billions of years. So for now, let's appreciate the sun for what it is. A life-giving star that has shaped our world and will continue to do so for many millennia to come. So we've journeyed through the birth, life, power, influence, and future of the sun. We've traveled from its fiery inception, billions of years ago, to its evolution into the radiant celestial body we know today. We've marveled at its immense power as the engine of our solar system, driving weather patterns and fueling life on our planet. We've witnessed its profound influence on Earth, from the role it plays in photosynthesis, to the way it shapes our days and seasons. We've peered into the future, contemplating the sun's eventual transformation into a red giant, and its final fate as a white dwarf. Through it all, we've come to appreciate the sun not just as a star, but as the heart of our solar system, essential to life as we know it. Next time you feel the sun's warmth on your skin, remember the incredible story of its creation and evolution. It's more than just a star, it's the heart of our solar system.